Welcome to the training program on Python. Today's topic is object-oriented programming in Python. So, object-oriented programming is a paradigm that's centered around object rather than function and procedures. It is different from the procedural language, and the concept of object means it is an instance of any of the classes that encapsulate data and function together. So, some of the basic concepts of object-oriented programming are: one is class, that is the blueprint of any of the object. The object itself, it is an instance of a class. Encapsulation is a concept that depicts the packaging or bundling of data and methods together in a single unit that is called the object. And what is the inheritance? Inheritance, as it sounds, inheritance means it follows the parent-child um, relationships, and it creates a new class from the existing class. That is, a parent class can produce some child class, and child class can inherit the characteristics of the parent class. And what is the polymorphism? Polymorphism means one object is there, but in different situation, it behaving differently on the basis of their data type and the class. And what is the abstraction? Abstraction is hiding complex implementation details and showing only the essential features of the object to the user. So why object-oriented programming is important? Because of it is more modular in nature. If you see the object-oriented programming language, you can make some modules and you can maintain that module independently so that a particular task can be maintained and you can depend. And another very important aspect of object-oriented programming language is reusability. Why reusability um, works very well? Because if a class is created, then that class can be reused across the project. So you need not create any of the new class. For that particular so reusability is very important in terms of when one class is created, and that class can be used across the project. So, and scalability, this is also very related to object-oriented programming language. It is easier to manage and scale our software project. And maintainability is also very high. It simply simplifies debugging and updating code. And productivity, of course, if a programming paradigm has the modularity, reusability, and scalability and maintainability, of course the programmer will be highly productive, and it enhances the programmer productivity through the use of the reusable libraries and the classes. So comparison. If we compare procedural programming language with object-oriented programming language, first of all, the approach is different. The procedural language is function-centric and procedure-centric. On the other hand, object-oriented programming is object-centric. And for management of the data in procedural language, you need to use or create separate functions to maintain the data, but in case of the object-oriented programming, data is encapsulated along with the function. Reusability of the code is very high through inheritance in object-oriented programming language, but this function is very limited in procedural language. So it is also very flexible language because of the polymorphic behavior of the object, where object can behave differently for different classes. The scalability is also very high in object-oriented programming language. It is easy to scale up for large software project than the procedural programming language. If we see history and evolution of object-oriented programming language, around 1960, this object-oriented programming concept came along with the programming language Simula. Around 1970s, the Smalltalk programming language. This is an object-oriented programming language popularized the object-oriented concept. In 1980s, C++ came. C++ was the enhancement of the C language with object-oriented um, concept um, that lead to wide adoptions of object-oriented programming. In 1990s, Java reinforced with object-oriented paradigm and with strong emphasis on cross-platform compatibility. And Java also changed the scenario of using any of the programming language which is object-oriented. It became very popular because it was cross-platform and the compatibility was very high. But after 2000 and beyond, the modern programming languages like Python, C++, and Ruby continues to evolve object-oriented concept and integrate them with new programming paradigms. So before starting the object-oriented programming language, we need to understand how it is related to real world. So suppose one builder is there, he is thinking of building a house. So what first of all he will do a blueprint of that house. So this blueprint can be considered in object-oriented programming language as a class. That class can be used to create one house, another house, and several other houses. So conceptually, this blueprint can be equated with the class, and the house itself it can be considered as an object. So you can see the blue distance. The blueprint does not have that much of physical existence, but the building has. So suppose this building has several data means it has a color, it has a size, it has many numbers of rooms, and several characteristics are there. Several attributes are associated uh, with this house itself. So that can be considered as a data. Suppose this house is uh, also a smart house. This house is also has a functioning kitchen. So this kind of functionality is also associated with this house. So this data and house uh, uh, so this data and the function is is encapsulated in this house. So in that way we can see the object oriented programming. So what is an object? Object are instances of a class, as I said earlier. If we consider this blueprint as a class, one house is the instance of that blueprint that encapsulate data and functionality. As I mentioned, that the color of the house, the number of rooms available in the house, these can be considered as the data, and others like functioning kitchen, smart facility, smart electric facility can be used as the functionality of that house. That both the things are encapsulated in particular object, that is the house. So this object became the fundamental block of any of the object-oriented programming language, and um, they are basically the real-world entity. They have the existence in the real world and with some attributes as well as some uh, behavior. That means the functions. So the type of the variables available in this programming language Python for there are three types of the variables. We can see in the object-oriented paradigm of Python. That is, one is a static variable, also called as class variable. So this variable is defined at class level and shared among all the instances of the class. An instance variable, this variable is defined within the init method, This is a special kind of method. We will see uh, in a while how init method can be used for constructing any of the class. And this suppose we are defining any of the variable within this init method, and is unique to each instance of the class. Local variable is what? Suppose one method is already defined, and we are defining one object within that method is called local variable. So as the instances, this Python class has different kind of methods also. Uh, these are the instance methods, class methods, and static methods. And type of the methods, type of the class methods available in Python. That is the instance method. Another is the class method, and the static method. So instant method are the most common type methods in Python, and they are defined with the self parameter, which refers to the instance calling the method. They can access and modify instance variable. So another is the class method. Class methods are defined with the decorator called class method decorator, and they can access and modify it using the class variable, which we have we have described earlier. So the last type of the method is the static method. Static methods are defined is with static method decorator, and it can be accessed through this. So some other type of variables, that is reference variables. Reference variables are refers to the object itself. Suppose we are instantiating any of the class that is creating an object, and that means we are referring we are creating some reference variable of that particular class, that is the object. Cell variable is very important. This is a default variable, and we will always pointing to the current object. Whenever we are calling self, the current object will be called through this self variable. So this method of constructor is one of the special method, and it is strictly typed, where we need to use the underscore init, then underscore bracket self, and after that we need to define our constructor method, and this method will be called automatically at the time of the creation of the object. And main purpose of this constructor is to declare and initialize instance variable of the object. The constructor will be executed once per object. So it is obvious that whenever we are calling any of the object, we are creating any of the object, then automatically the constructor method, that is init method, will be called, and it will run once when we create one object. So another is your object level variable or instance variable. If the variable values will be varied from object to object, that means it is specific to object, then it is called such type of the variable is called the instance variable. Place of declaration of the instance variable is declaration can be done inside the constructor by the self variable, and declaration inside instance method by using the self variable. From outside the class by using the object reference variable, and deleting of the instance variable from the object. That was the class and object concept in Python programming language. Another very important concept of object-oriented paradigm is inheritance, where inheritance allows a class to inherit attributes and methods from another class. Suppose we have a class, and we need to use that class, use the functions and attributes of the class without affecting anything in the class. We can create another class that can automatically inherit the attributes of that class. The purpose of this uh, inheritance concept is to promote code reuse and establish a relationship between uh, these are the some type of the inheritance that is single inheritance where one class inherits from superclass, and multiple inheritance suppose one class inherited from more than one class. Hmm? Another is your multi-level inheritance where a class inherits a derived from already it is a child class of another class, and from that child class we can create another class. Then this is for the multi-level inheritance. And hierarchical inheritance, suppose multi-classes are inherited from one superclass. Okay, so multiple classes has inherited from one superclass. For example, suppose one animal class is there, from that class one dog class, one cat class, one lion class has been inherited. So this kind of example can be used for this hierarchical inheritance. And hybrid inheritance, what is the combinations of any of the two or more type of the inheritance can be considered as the hierarchical inheritance. So for code, you can see here the class is the parent class. First is the parent class. This is a class, and for inherit that class, we need to create another class called child, and we need to write the parent in the bracket. So in that way, and all the inheritable methods and the data can be inherited in um, the child class. I have mentioned the inheritable because we will see some of the special cases where some characteristics, some behavior cannot be inherited in the child class for example. So for example, this is an animal class, and animal class has a method, init method to initialize the object, and the speak method that is a class method. And suppose we have inherited a class called dog that inherit the characteristics of animal, and then we have override the speak method in case of the child. So here we are using the animal class with some specialized characteristics of the dog class, where speak method can be changed here, and we can use this inherited method where we have already incorporated the characteristics of this animal class. So okay, one concept of object-oriented programming language, that is method overriding, redefine a method in the child class that exists in the parent class. So using the super method, where animal class is a class where speak a method, this is a method called speak, and it returns some sound. Okay, so another class we have inherited from the animal class called cat class, and we have override this method called speak with for the cat class. Suppose another class we have defined, that is a dog class, where super keyword is used to change in the init method of the parent. Example of multiple inheritance, where one base class is there, another base class is there, and the derived class inheriting two base classes, base class 1 and base class 2. So this is an example of multiple inheritance, and this is the implementation of that, and we will see in the practical session how to do that. And we should not use inheritance where it does not require any code reviews. Logically, in object-oriented programming language, is very much related to real world. So we need to find out whether a particular relationship is a parent-child relationship or is a relationship or not. If it is so, then only we should use the inheritance, and we should avoid inheritance hierarchy. We need to keep it very simple. The modularity and uh, the readability of the code should be well maintained. So the next concept is your encapsulation. When, um, what is encapsulation? Encapsulation is the bundling of data and method that operate on the data within a single unit or class, and restricting access to some of the object components. Purpose of the encapsulation is to protect the data from unauthorized access and modification, to enhance modularity and maintenance. So the concept of polymorphism is also very important in object-oriented paradigm, and that is called poly and morph, which is derived from the Greek word poly means many and morph means form, where polymorphism refers to the ability of different classes to be treated through the same interface. So, where the interface is same and the functionality is different. So in that way, the polymorphic behavior of any object is reinforced, and unified interface. The same function and method name can be used on different type of object, leading to different behavior based on the object type. So type of the polymorphism, one is compile time polymorphism achieved through method overloading. Uh, Python doesn't support method overloading directly, but in case of the overloading, we can achieve a static kind of polymorphism. And what is runtime polymorphism? It achieved through method overriding, which is the primary form of polymorphism in Python. So in these lectures, we have covered some basic of the plan. This lecture we have covered basic of the class and objects, and we have considered the class variables, and we have see how inheritance work and what is the importance of inheritance and where the suitable time of using the inheritance. And there is the encapsulation, where uh, where we discussed how the concept of bundling of data and function together, and the polymorphism through overloading. So writing any of the class, you need to use the class keyword here, and you can write any name of your class. This is your class, so you are writing the name of the class. So some of the basic convention of class name of the class is you cannot use any of the reserved keyword, which has been used in Python. You can use the capital letter start a class. This is a basic convention. You can also use the small letter, but the basic convention is to use the capital letter. And you can put any of the identifier. Suppose you are able to write the name of any of the identifier, then you can put that name to the class. So that's it. Your class is ready, and I'm running this code. Taking longer. Yes, so my class is ready. Okay, and after that, after writing my class is already created, and here one doc string. That means the documentation string I have used here. We need to use this quotation and uh, and complete this quotation and put something about the class, and you can that is kind of quotation of that class. And if you want to see the documentation of any class, you can use one method called, suppose this is the class, and this method can be used underscore. Okay, so it is written that I have written the doc string. So you can also write this class, and it is showing that this is all class. So suppose you have written any like, suppose you have written some information about the class, you can get through this. Another method called help you can use also. It's a help method, and you are writing this. Okay, so help method will help you to find what is written in the doc string, and other description you can also get from this help function. Okay. Now, suppose I have built a builder class, as I mentioned that suppose one builder is want to create a house, you need to make a blueprint of that house. Suppose here a builder itself a class, and some of the functionality and some of the data are associated with this class itself. So this is the init method, and this is used for constructing any of the object of the builder class. And this is the self method, as we mentioned. This is a default method, and then two data, that is name and experience, is added here, and where name and experiences can be added through this self method. Self dot name is equals to the name. So suppose that the name of the current object is the current object, that means builder object is equals to the name which is given here. Whenever we will create a method, whenever we will create an object of this builder class, and we will put a name here, automatically the name is set to the self name. Name means the name of the object will be set here. Accordingly, experience will be the same. Okay, then a method is already been defined, and that is build house. Build house, where self is a default variable, and this what this self is doing. Self is basically establishing a connection between this build house method and the builder class. So if we remove this self method, then the connection will not be there, and it will throw some error that that one default variable is expecting admin one, not putting that variable into that. So what this method is all about, it is basically returning a formatted string, where first of all it is taking the name then it is putting some of the string that is building a house with this year of experience. Suppose I am creating what it is happening. I am creating a method, I am creating an object, and then this object can call the class method, that is build house or build bridge. So then if I calling this method, if I calling this method through any of the object created by the builder class, then it will return the name of the suppose Rahul is building a house with 8 years of experience. So this kind of access is allowed here. And another method is called build bridge, where again we are using the self variable for connection between the main class and the objects. Then it is returning some string where we are taking name as a variable, and the variable and putting that into a formatted string. So these methods is basically, these two methods are basically a format of the method where this portion can be used for implementing method in your way. So for just to show how a class can use some attributes, that is the data, and the method of that class can be accessed through your objects. So now suppose we are creating two objects of a builder class, where the builder 1 and builder 2. See, if you can connect the example I have given, that suppose a builder is creating a blueprint of a house, then a house itself a object. So here builder is a class, and suppose builder Rahul is an object of that builder class, or builder Alice or builder Bob is a crop particular class. So if you can connect the example I have given, where blueprint can be considered as a class and the actual object is considered as an object. Here builder 1 is the actual object and builder 2 is another actual object, where we have called this builder bracket and bracket, where we are putting two arguments. One is the Alice and one number. The number, this Alice will be set to where it will set to this here it will set, because whenever we are calling this building builders and the builder first bracket and first bracket, it will call the init method. When it will call the init method, then after default variable it will expect the name argument and the experience argument. So we are putting this name argument and the experience argument. So automatically the name and experience of the builder class will be initialized. So it is a kind of constructor we have already discussed in the earlier part of this lecture, and where this builder is initializing this builder 1 object. When we have built this object, we can also call the method which is already been created in the class. So this is builder 1, and this is builder 1 is calling the build house, and builder 1 is calling the build bridge. Again builder 2 is calling these two methods. So if we are calling the build house method, then Alice and 10, that means Alice and the experience is 10. So it will, if you see this method, so the output will be Alice is building a house with how many years of experience? 10 years of experience. So it will show Alice is building a house with 10 years of experience, because the method is set the method used here, using two variable called name and experience, and we have set the name and experience is Alice and 10 here. So if we see, I'm running again, and here Alice is said. Alice is building a house with 10 years of experience, and Alice is building a house with building a bridge with 10 years of experience. Accordingly, Bob and 5 years. So this in this way we can initialize a object, and we can create objects from a class. So so this is the class concept. Up to this, in this hands-on, what we have done, we have created a class, and we have seen what is the convention of creating a class, and then we have seen also seen that how can we use the docstring and help method to know about the class which has already been created. Then we jump into the builder class, where we have initiated the init method with two new uh, two additional attribute, that is name and experience, and that name and experience is set to the name and experience variable of the builder class. Then we have created two methods called build house and build bridge, and after creating the builder class, uh, we have seen how it is whenever we are creating any of the object, initially it calls this init class. So this is very important concept. Okay. So now we have a builder class, but we want to see uh, that how many times this builder class, how many times this builder class is instantiated. Okay. Suppose here in the previous example we have created two times the builder classes. So suppose we want to see how many times we have created the builder classes. So for this example, um, we can take one example, that suppose one car manufacturer is there, and we want to see that how many cars are created, how many cars are built in a particular season, and we want to count that. So in that case, what we can do, we can use a class variable. The class variable is initialized here, that is the builder count, how many times the builder can be created, and one very particular concept of initializing any of the object. Whenever we are trying to create any of the object, then it's obvious that this init class will be run. So what we need to do, we need to set a counter and increment this counter within this class itself. So we do same things, that is name and experience we are setting to this self variable, and another line we have added builder dot build count in the increment function. So we have seen that every time it have discussed several concept of object oriented programming through Python, and it's last section of hands-on discuss the inheritance. Here the animal class is implemented where the constructor is created, and two methods for making sound, another method for printing the name of name and species variable. After that, how we have extended or how we have inherited the animal class, like dog is animal, which is inherit the property of the animal class. So in this section, we have derived a class called dog class from animal class, and this dog class is inherited all the inheritable property of animal class. breed of this current dog class. Then make sound. This make sound need to be implemented in this dog class, and for make sound. Uh, that means this make sound class is implemented here, and it is a dog class, so it is returning a bark sound. And the third, this method is simply printing the name and the breed of the species of the dog class. In the similar way, when we are creating a cat class from animal class, then we are re-implementing in this cat class to the super keyword. When super keyword is required, suppose sometimes when we are trying to initialize parameters that in the parent class, but in this class, in this child class, that is cat or dog, we do not have access to the init method parent class, that is animal. In that case, we need to use the super keyword, and this super keyword helps in initializing species name and species here, and here species is cat, and accordingly we make different terms for make sound class, cat class, and similarly we have created string class. Reusability of it increase the reusability code where we need not to write the base class and make the derived class according to requirement, and we can use that. Second important concept, the second pillar of object-oriented programming is encapsulation, and this encapsulation. So up to this we have discussed the inheritance so far. Now we will discuss the encapsulation, where we have extend our animal class into fish class, and in inheritance likewise we have override the init method here through this super keyword, where we have modified and set the species attribute as fish, and another special kind of variable, that is water type, where we have used this to underscore. um, that means we make this water type variable as a private variable. Okay, so this what private variable means, private variables or private attribute means we cannot access, user cannot access this variable directly. To access this attribute, we need to use some special kind of method called getter and setter, where get water type is the getter method, where we have used the self variable, and we are returning the water type, that is a private kind of variable. For setter, if the water type is fresh water or the salt water, then we accept the value of the water type and set the variable value as fresh water or the salt water, whatever the input given by the user. But if user input is different from these two attribute, then it will return a error, and it will reinforce uh, uh, that you need to add fresh water or salt water. In this set of code, what we are doing, we are basically encapsulating our data into a class, and we are basically hiding the data from the user. And when the data is exposed, it follows some rules through this getter and setter method. So this whole set of code is enforcing the encapsulation concept. Another is your polymorphism. Polymorphism, you can say, we have discussed that same method, same name of the object, and but it is behaving differently on the basis of the class. So if we see this is a method which is called the animal sound, where we are uh, what what it is depicting, that we are um, running a loop where we can put the name of the all the like set of the animals, and according to the animal type the sound will appear. So same method, same method, same name, and but on the basis of the object type it will behave. So this kind of behavior is a polymorphic behavior. And another concept is another pillar of object oriented programming language, the abstraction, where we used some abstract method. Suppose for vehicle example, we can start a engine simply like uh, switch on a button in your car, or like twisting your key in a car. But we are not bothered, the drivers are not bothered about any of the implementation inside the car, what is happening inside the car. So what abstraction means, abstraction, although the term sounds very hard, but the conceptually what this object oriented programming is reinforcing, that all the details, all the minute details and unnecessary details which is not necessary to the driver, suppose, will not shown to him. uh, in that way we are basically abstracting the complexity from the user and the user. So these are the two abstract methods. This is a decorator. There are many decorators available in Python programming language. We have seen some of them, and this abstract method is designating this part for the abstraction. It is not implemented here. It will be implemented in your child class, and accordingly you can see that in child class, car is a subclass of vehicle, and this is for starting the car and stopping the car engine, and for the bike it is stopping the bike and starting the bike. And we can reinforce the abstraction. We will find that suppose we are creating a object called dog, and which is a object of the dog class, where we taking attribute of the name and breed, that is body, and putting this dog. Uh, okay, body is a golden retriever dog. So what it is printing, what we have implemented in the class station, where we have created the dog class, and this this method, this dog, um, what it is what is just printing, the given name and the breed, species. When we have called this dog, when we have called this dog, automatically this constructor ran, and this species is set to dog. That's why we have set dog, the name and the breed, and then it will and automatically is set, and that the species is a dog. In that way it works. In case of demonstrating encapsulation, where the we have printed the fish, where uh, fish is printed, that name is the fish that lives in salt water. So after that, the set water type method called, and the water type is set as fresh water. We have seen that we are reinforcing, uh, we are giving some kind of compulsion to create the fresh water or saltwater fish. So in that way, it is this method set water type is setting the value fresh water for the fish class. In that way, we are uh, using of the getter setter method, and we are creating we have created a method called animal sound, where we are inputting a list called dog, cat, and fish. And dog, cat, and fish already been um, initialized with these sounds. What it will do? Let's see. It will take animals one by one and put the name, and it will make sound accordingly. So if it is a dog, then it will bark, and accordingly fish and cat and fish it will walk. That means where dog name is set as Buddy, uh, cat name is set as Whisker, and fish name is set as Nemo. And accordingly, the animal sound is can be retrieved can be retrieved from this method. And next, if so, then run this. Okay. So these four methods, what it will do, then if this object is from car here, then start engine will work for the car, and if the object is bike, then it will work for the bike. So for, for this, we are basically abstracting the actual implementation of the start of the car. So in that way, we are seeing the abstraction.